फर्स्ट विंडो क्वेश्चन का होना चाहिए ना, नॉट वर्किंग.
Hello, welcome to zdeciphers.org. My name is Cortelia Kataria and I'm a 9-year-old computing explorer and problem solver. Today we're going to be doing a BIO problem, and it's going to be from 2019, round 2, question 2, and its name is Trail. So this will be part of a BIO kind of series that we'll be doing. We're also doing a maths one and a Leet Code or Geeks for Geeks one. Right? So the question says, an explorer is moving across a rectangular grid of squares, leaving behind a trail. Keen to experience the unknown, they only move into squares that do not contain part of the trail. The trail fades over time, and the explorer can re-enter a square once its trail has disappeared, although they will leave behind a new trail. If the trail fades after n moves, then it means that the trail in a square will disappear once the explorer has finished moving n times. The explorer is following the self-instructions. So if the instructions indicate left or right, then they'll turn 90 degrees in the corresponding direction. Otherwise, they will stay facing forward. The explorer will then move to the adjacent square in the direction they are facing, and so long as it does not contain the trail. If this is not possible, they will turn 90 degrees to the right and try to move. This will be repeated until they have moved or tried all 4 directions. Each entry in the explorer's directions is either there's L, that's left, R, right, or F, forward. The explorer works through the entries in order, restarting at the beginning once they have all been used. For example, suppose that the trail fades, after the explorer has moved 8 times, and their instructions are F, L. In the diagram, the arrow will indicate the explorer and the direction they are facing, with the numbers indicating the age of the trail. So the explorer first moves forward and then moves to their left. And then after the second move, they are facing in the new direction, and the trail covers 2 squares, and I guess the question keeps going like that. The explorer will now restart their instructions, another move forward, and then move to the left. Wait, I already said that. Another move forward in the direction they are facing, followed by a move in their left. And it also says some other stuff over here. And so I think we should go to the working out, because it's been about almost 10 minutes. So I think now I guess it's more of an implementation. I guess it's more of an implementation problem than topic problem. So
Right.
yeah. So I'm pretty sure that we can just. I'm pretty sure what we can do is just. So I'm pretty sure what we can do is make a variable called path in a function, probably. I think so. This. Yes, something like define explorer. I'm writing in Python also right now. Yeah. So define explorer of, and then path, and and I'm pretty sure we'll
So, what do we need to output?
and we need to output the Wait a second, let's check the question again. It says we need to wait 1 second, just there we go. So yes, we want to output the coordinates of the explorer after making their move, and I guess it starts at 0, 0, facing 0, 1, and to their left is -1, 0, and their right is 1, 0. Okay, so let's get back to the working out. So I guess we also need to pass variable hold. Wait a second, just zoom out a bit. It's gonna be path. And so actually let's just pass the direction for left, because right is just the opposite of that, so we can just do negative that. And left. And
So how will you represent the grid here?
How I'm going to represent it is just going to be so it's going to be the grid. So what I'm going to do is I'm going to pass the I need to pass the width and height of the grid. So I guess the question for that particular, so let's call it H and W. Okay. And also in path we're going to add the coordinates of it. Okay. And I guess we also need a variable. So, yes, we also need a variable to
Okay.
we also need a variable to say where it is now. So pause. Okay.
So how are you representing the grid at the first? Like, what is the def explorer function doing?
So it's going to basically do what the question says. Just iterate, just keep doing that thingy until until we have to stop.
Okay. So if this is an implementation function, so we don't need to actually write it on paper first, right? We can jump to implementing it. I think that way it will stay clear.
Okay, so should we start? So yes, we should start coding then.
Yeah, we can start coding this.
Okay, there we go. And where is Python there? Wait. Wait 1 second, need to do something. Okay, there we go. So yes, maybe instead of using a function, I guess we could use a class, because then it'll be more Let's Explorer.
Why do we need a class there?
Just
Okay, you can use a class, no issues with that.
I just like to use the class more than a function in these kind of problems.
Okay, yeah, sure, no issues.
Yes. And then, so what is it going to input? Well, there was the path, left, which way is left, and I'm pretty left, and
What exactly is left?
which way left is for the observer. Actually, we don't need to do that because the question says that to start it's always in some kind of thingies. So self.path, it hasn't travelled anything, so it's just an array. Self.left, that's which way left is. Okay, and then the question says that was -1. I think it's -10. Let's check the question. So it is, it's -10. Right, and self.forward is that's 0,1, and it's self.right is 1,0.
It kind of depends, right? Where is the person looking?
Yeah, but the question says that it starts at 0, 0, and and to the left of it is -1, 0. Forward of it is 0, 1, and to the right of it is 1, 0. And also these variables don't keep track of what is the position that's left or right or forward. They keep track of which way left and forward and right is. So
Okay.
yeah, so you need to add the position to self.left to get where to move it. Anyway, so
Instead of storing its left, forward, and right, we can just store it and the direction it's looking in.
okay, so I guess that would be self.forward. 8, 0, 0, 1. Okay. And is that all? We have to also specify the height and width. H, W. Self.h equals h self.w is w. Okay, and h and w are height and width of the grid. Okay, and then also we have to add. We also have to pass I forgot what it's called.
Has the height and width been mentioned anywhere?
No, but since we're not storing the actual grid, we have to keep track of the height and width, and we're not storing the actual grid because wait, I guess it doesn't say the height and width. I guess that means it's. Oh, I got what you mean. I guess that means that it's infinite. Right.
I don't think it's infinite. Let me just see once. Looks like it's infinite only.
Yeah, yes. Also, it follows some instructions. Let's remove H and W. Self.instructions. That is instructions. Let's actually call it move to. And then
We're getting 3 inputs, right? One is the time it will take for the trail to disappear. One is the number
yeah.
moves
And
and
the number of what?
instructions, like moves.
Right. So n moves. So fade time, n moves, and instructions. Okay, so there we go, and I think that's all. Now now we'll have to define an explore function. Of self. It's then what we'll do is
To store the grid as well, but not as a 2D array. Maybe we need to store it in some other way. Can you think of another way to store the grid?
Not sure.
So think about it like this: you only need to store the cells where the trail is there. You don't need to store the whole grid. You only need to store specific cells, and you need to store the time they will.
Yeah, I'm already storing it as self-thought path.
That will be an array, right?
Yeah, it will be an array of the coordinates of where the coordinates of the trail, and when.
And then you need to look up coordinates to make sure they're not like visited again and again. So the lookup time is way too long for array. You need someone where you can roll out.
I guess we can use a set then. It's pretty fast.
Set or a dictionary, because you need to store the time as well when you reach a particular cell.
Yeah. I guess the dictionary will work then. I'm not sure which way to do it. Should I do the time as a value or a key? Maybe value, I think.
So you need to store if like when a cell was visited. So you can store the key as the coordinate and value as the time.
Okay. So then define. Yes. Wait. Okay, so I guess what we can do now is first what we can do is just instruction. So self dot move to. So that'll be the instructions. So for I is and for I in self dot move to, if I is F, then that means also we need to store the coordinates. Then self dot coordinates plus equals self dot forward so if I is let's do L, then I will also need to append self dot self dot.
Self dot coordinates is a tuple, right?
Yeah. So then it'll be self dot coordinates of 0 of 0. Okay. Plus self dot forward of 0. There's probably some inbuilt Python function to do this, but it's not. But it won't waste too much time for the program and for us. So if ISL then we forward to self dot path of self coordinates. That is the this shall be 1. Right, so then if
You need to store the time when you reach, so maybe you need another variable to store the time.
you need what variable?
You need to time when you reach a particular coordinate, no? Oh, you either you do like for I in range self dot move to. So maybe make a variable or just do I in range.
I set equals to that equals to 1, so then I guess I'll set the time to 1.
It should equal to the time when you arrive at the coordinate, no?
Yeah, and that's and it's I thought it's the number of amount of so like the amount of time to the amount of time it's been after we've reached it, so then
Can you say that again?
if it was the amount of time after we've reached it, so
Okay, so what I'm saying is you need to mark the trail, right? After you visit a cell, you can't visit it for some amount of time, right? Till the previous trail does not fade from it.
yeah.
So if we can store the time at which we reach a coordinate and then we keep a track of the time, we can just know if we can enter the coordinate again at the current time or not. So we can create a variable, let's say self.current time, and we can mark it as 0 at first, and then every time we visit a coordinate we can keep incrementing it.
So yes. That's pretty much what I'm doing over here. So then, what I'm going to do is when we visit a new coordinate, then I'm going to increment all of them plus to add 1 at the end. I mean, before we move new coordinates, then we need to increment it over here. To we need to increment the self-dot path over here, and then you mean we need to check whether we can go in that cell? Right, so this if self, what we can do is if self wait. Yes, I'm going to do it over here, and if self dot and pass self dot coordinates in self dot path, and then if wait, install those x actually. So if x in self.path, then if self.path path of x, if self.path of x, if that is if that is less than or equals to self.fade time, then we can just if that's more than self.fade time, then we do it, and self.coordinates equals x, otherwise here self.coordinates equals,
So it keeps on fading, right?
yeah.
So you need to mark the current time, and then you look at the time when you reached the cell last time. Then you check that if it's faded or not.
Yeah, that's what I'm doing.
You're marking the time when you reach the coordinate as 1, right? On line 14, you just wrote that cell.path equals 1.
I mean that's the coordinate before it. Before the forward. Before we move it forward.
How does the time get updated?
I'm going to update it over here. So I was doing the code for the actual move thing first. We can do that if
Take a variable as current time.
but I'm setting it to 1, and that's the current time. in self.path, and that's one. So what we can do is just go through all of the key value pairs in self.path, and then set that to that +1. Right, so what we can do is for I in self.path, and self.path of, wait, no, not I, J, self.path of J plus equals 1. Right, then I'll keep updating it.
Okay, you don't need to update all the paths every time, no?
Why not every time?
Okay, so let's say you start at 0,0 at time 1. Okay. Now let's say the fading time is 8. So you know that if you are at time 9, 0,0 is faded. Is that right?
Yeah.
So at any point of time, if you want to check if 0,0 is faded or not, you can just look at the current time, which is 10. You can subtract the faded time from it, -8, and like the value is 2, right? So that means it is faded by now.
What I'm doing is I'm setting it to the amount of time since we've visited it. So then it's going to be 1. Then when we visit next cell, it'll be 2. Then next cell 3, and then when that gets to 9, then we'll know it's been faded because of this condition.
Okay, sure. Do it your way as well.
Right, so if it's left, then yes, we can just but instead of forward, we'll do left, and I guess left is and left is basically the reverse of forward.
So you need to look at the current direction your character is looking at and then move it to the left. So instead of storing only the coordinates, you also need to store the direction it's looking at right now.
Yes. Yeah, I'm doing that in self.forward. I guess I forgot to do the updating.
Yeah, so you'll need to update self.forward every time then.
Right. So if we move forward, then wait, we don't need to do it in when we move forward. We need to do it when we move left, I guess. So yes, so self.forward like that. So when we move left, then forward, and equals forward of 2 to this one. Alright, so we'll just be reversed because then it'll just be reversed because forward is 1 0. If we're in the starting position, left is 0 1. Oh, wait, what was it? 0
Okay, what if it's looking at left? What if it's looking up and then it goes to the left?
So I've stored the variable for. I stored the variable for forward, and I'll see if it's looking left, then that means forward in the system. So wherever it's looking, then that is forward. Self.forward for the class.
Okay, if it's looking, let's say, towards the right, then it makes sense that if it moves to the left, then we can just reverse. It's looking at 1, 0. But let's say it's looking at 1, 0, and then we have to go towards left. So where should it look then? Minus 1, 0, right? 0, minus 1.
Yes.
Does that make sense?
Not really.
Okay. So currently you're looking at 0, 1, right? That means you're looking towards right.
Yeah.
Now let's say we get a left command. Now where will the character look? 1, 0?
Yeah.
Now let's say we give another left command. So it has to look towards 0, minus 1, right?
Okay. So I guess it's not reverse. Yes, it's.
So we need to look where it's currently looking, and then we need to the self.forward accordingly.
I'm not sure. I think we should store separate the variables for self.left and self.right. Then left, I think the question said it was left is minus 1, 0, and right is 1, 0. Left is minus 1, 0. Right is. Okay, so then we can just use self.left.
Left does not mean minus 1, 0, no. Left, so you need to look at it with respect to your current direction. If it's looking forward, then left means to go towards minus 1, 0. Sorry, 0, minus 1. If it's looking towards right, then left means to go towards 1, 0. It is.
Let's just see the initial one. So, if we go to the question, then it says to the left is minus 1, 0, and to the right is 1, 0.
Yeah, it's at the start.
Yeah.
Like when it's at 0, 0.
Yeah,
Front facing
we
0.
are going to update it in the self. So wait, if it moves left, then it's self forward turn into self dot left, and self dot left is so if it moves left, then yes, it's
I can't see the code Kodala.
I forgot to switch to coding. It's then so wait, let's first do self dot left. Dot left is self dot forward, and it's kind of negative self dot forward, so negative self dot forward 0, comma negative self dot forward of 1. But how do we? That doesn't work. X is self dot. X is a copy of that. Y is self dot right. Z is self dot forward. Copy of. So self dot left is negative z of 0, negative z of 1. Self dot forward is x.
There would always be negative of that.
So wait. So if it moves left, then it's that. I guess left now. If it moves left, this when it moves, I think it will. Good.
Okay. So look at the current direction you're looking in, and then so if you're looking at 0, 1, then update it accordingly. Else if you're looking at 1, 0, then update it accordingly. That's how you should be doing it. Is it like sorry?
Forward is the way it's facing, and left is what is to the left of it and what's to the right of it. So it's already in respect with the Explorer. So
Okay. The direction part is a little confusing, right?
Yeah, so. Right, so then. So. This is how to update it, I guess. And otherwise. Right. And we can. Say, oh. Right, then if it's moving right, then just self-stop right, self-stop right, and instead of left being negative, it will just be Z, and self-stop forward will be negative X, self-stop right will be negative Z. Wait, not X, Y, and Z, because that's already in use. W. Well, and stuff X, Y, W. I think it. So now I think we have to now we have to if it's less than the fade time, then we have to look right, and I guess so. And maybe first of all, maybe we can let's just do a little bit of a break before we do it. Stop streaming for just a minute. Maybe. Right. Okay, so we've decided that if 1 second. Anyway, I'm just trying to find. Okay, so we've decided that we won't do the complete solution right now, but we're just going to summarize what we've done. So we built a thingy, and maybe the next thing to do is use it for. The next thing we can do is try and do it, and so if it's blocked by the path, then we can try and keep turning right to see whether it is, and
right.
it's already 6 o'clock. Right, so yes, what we need to do. Right, so I guess we can just talk about the actual solution now. So
Okay, so yeah, so what we can do here is first we need a variable that uh, counts how, like, where are we at this point of time. Basically, it marks the current time. It always increases when we move to when we do another move. So let's say we are at so one variable tracks the current time we are at, and then there are other variables that track the current position we are at and the direction that we are currently facing. So if we are at let's say any position x comma y and we are looking at the right side, then we need to update our direction, and a L command comes, so we need to update our direction so that our direction now looks towards the top. Then we need to update so that our direction needs to look at the left, and then towards down, and finally towards the right. So we need to make a cyclic kind of directions. Similarly, like the right side, uh, like the R direction will also be coded. Yeah, apart from that, I think our solution is kind of functional. We need to make, of course, a few changes. Uh, but apart from that, I think we have written the correct thing. Um, yeah, so after that, we just need to simulate the moves and we'll be done with the solution.
yeah, right, so that's the summary of what we need to do. Yes, and so yeah. Thanks for watching, viewers, and let's